Hello, everyone. Thanks for coming along. So just for half an hour, I'm going to be just talking through my experience of working, particularly with children, on exciting them about learning to code. So half of my talk will be about what I've learned in that kind of experience. I'll talk a little bit about why I think it's important. I'll also do a live demo to try and convince anyone here who perhaps isn't a coder or is perhaps a slightly nervous parent that it is really, really easy. So I hope everyone is here for the right reason. We'll kick off. So I'll talk about creative coding. I'll talk a little bit about the tools, and there aren't many. In fact, you've already got them, I suspect. I'll do a live demo. I'll talk about the lessons learned and point you to a few resources. So what is coding? It's giving instructions to a computer to make it do something. Now, that can be for reasons of calculating costs and finances, which, sorry, did someone say something? Yeah. Which can be perhaps less interesting to children. Many of us find it's really interesting to get computers to create visual art, sound, music, create 3D forms. Now, these instructions, this language that we talk to computers with, unfortunately, it's not English. If I say, hey, draw me a circle or draw me a banana, it's not going to understand that. I think Google's getting quite close. So computer languages need to be precise, unambiguous, consistent, and that can mean that they're a little bit kind of off-putting. But I'm going to show you today that actually today the languages that we can talk to computers with are really easy. So just to give you some examples of the kinds of things that people do create with computers, this is a fractal. It's called a Julia set. It's a mathematical object. In fact, it has an infinite amount of detail, which some people find interesting. You might have seen the Mandelbrot fractals. So many of us get excited about this and want to learn how to make it. I think children particularly are fascinated when they see beautiful forms like this and want to kind of learn how to do it. And it makes them kind of think, okay, if I need to learn a little bit of mathematics, then let's do that. It's a great way to excite kids. Certainly mathematics lessons in schools don't always kind of provide that kind of excitement. Here's another example where we're exploring, it looks like a tree, but we're exploring the idea of recursion, which is an important mathematical and computer science concept. It's the idea that things are defined almost in terms of themselves. So a tree is a branch with a smaller tree on it, or a couple branching off, and so on and so on. So these abstract ideas, when we play, and I use the word deliberately, when we play with computers, it's much more fun, much more immediate, much easier to understand some of these concepts. So coding to create beautiful forms is a great way of learning important concepts like recursion, for example. This is just another experiment where it's animated. This is from one of the students in one of my groups, where they've taken this idea of recursion and created really interesting patterns here. But if you look closely, you'll see that they are circles with other circles connected to them, with other circles connected to them. So it's a simple idea, but it really brings it to life in a really interesting, beautiful way. There's a huge amount we could kind of cover in terms of what we mean by creative coding and algorithmic art, and I've had to just pick out a few examples. Here is somebody exploring the concept of a kind of randomness, so not pure randomness, a randomness called Perlin noise, which is actually really useful in a range of kind of industries. In fact, the guy who invented it won an Academy Award for technical services to kind of the film industry. I think some of the early films like Tron, and I think Toy Story might have used it as well. So when people play with this kind of noise, which is a little bit more well-behaved than pure random noise, you can have creative kind of uses for it, like creating landscapes, creating surfaces of planets, creating textures. And it's a way into kind of, for those who are curious, to say, well, how does it work? And that's a much more interesting way into learning about mathematics. And we're all trying to get children to kind of, encourage them into subjects like maths, physics, and doing it in this way, I have found it's much more successful. This is the same concept of Perlin noise, creating an alien landscape. I might show you the code later. It's extremely simple. But when I put this in front of children and say, we're going to do this today, they're excited. It looks like some planet from some alien galaxy. This is the same underlying method of using Perlin noise. If I hadn't used Perlin noise, this would just be a regular grid of dots, but each of the dots has been moved around according to this noise. And you can see it's not pure randomness, otherwise it'd be a mess. It's some kind of constrained randomness. Here we're using the same concept again and exploring it in a different way. And here we're following ants whose directions are set by this noise. And the visualization is quite mesmerizing. So the point of showing you this is, rather than kind of coming at subjects like mathematics and computer science from the usual dry black and white textbook pages, if we come at them through interesting forms like this, first of all, they're engaging. And secondly, it kind of piques people's interest to say, well, what's going on? I want to do this. I want to understand. I need to learn about coordinates. The teacher's been going on about coordinates. Okay, I'll pay attention. They're talking about repetition and other kind of abstract concepts. I really want to do it. And I found that kind of has worked much better for kids, and I'll show you some photos of kids doing that. Creative coding is not just about showing things on a screen. There's a real trend and a movement to kind of reconnect back with the analog world. So there's a trend at the moment where people are coding to create patterns and designs, which would be difficult to do by hand, but they're realizing them with, say, pen and ink on paper, using plotters, for example, and that's kind of interesting to see. This is a Japanese artist who, again, creates very kind of natural forms that look like brush, pen, ink, but it's actually pure mathematics. Every single dot that creates these kind of brush strokes is governed by a simple mathematical function. Who would have thought mathematics was exciting, beautiful? And at school, kids really often dislike things like trigonometry. Oh, trigonometry class today, sine waves and cosine, and too often it isn't made interesting. But when you come at it from the angle of let's create interesting animations and designs, these are just sine waves with varying amplitude, and we can have sound with this as well. And that's much more kind of engaging, and it makes it real. What is this mathematical function? It's just something that goes up and down. Here's something that one of the students did, one of the children did, where they're combining the concept of randomness, throwing dots on the screen, but actually varying their size after they've been placed according to sine waves. So what that child has done, who I think was under 10 actually, has taken this so-called advanced concept of a sine wave from trigonometry class, which is taught in secondary schools, and used it successfully to create an undulating pattern. Now, isn't that amazing? Somebody who's under 10 has managed to use things that are taught to 15-year-olds, 14-year-olds, and they kind of sometimes find it challenging. And the way in was not, we're going to learn all about the mathematical properties of it. No, we're just going to take the salient point, which is a sine wave goes up and down, and we're going to use the up and downness to kind of regulate or kind of design the size of these dots. This is another, I think, really nice form, and it's just the path that's created when you follow a cog going around another cog, going around another cog. So a system of 3 cogs, I think this one is. It's interesting, isn't it? That's another one. And those who are kind of interested in more traditional kind of approaches to art, the coding approach really helps us meditate on, well, what is color and how does it work? How does light work to mix? And this is an experiment where somebody's been trying to understand mathematically how colors are related when they're close to each other. What does it mean? I think it's quite calm kind of composition. We can't kind of not talk about computers and graphics and mathematics without talking about chaos. And this is a mathematically chaotic function which has developed some order, so order coming out of chaos. And you might not be interested in the mathematics, you might just be interested in the kinds of forms that are created. We can't talk about computers and code without talking about AI. So this is somebody who's teaching a robot to perform verse, and verse that is learned from digesting using machine learning algorithms to distill large volumes of text. I think this one was on pop songs, actually, so the output of this robot was quite interesting. But the idea is that we can demystify and make machine learning and natural language processing less scary and more approachable by having a playful interface to them, by allowing people to kind of have access to the tools and play in a way where there's no danger or cost to failure. And we build up our kind of confidence and understanding of how these things work. This is one of my own kind of research projects at the moment, where we're using what they call generative adversarial networks to kind of learn to create kind of images. And my own kind of work at the moment is try to create images which have an emotional content. And the interesting thing there is, well, what does a machine learning algorithm learn when it's being taught to recreate happiness or sadness? That's something I'm kind of working on at the moment. So there's just some examples just to show you a little bit of the kind of diversity in this field of creative coding. But why is it important? Well, you know, the whole world around us, I'm going to show you hopefully a picture of the globe. Everywhere, the world around us is increasingly digital, from booking airlines to seeing what time it is, from an internet kind of time server to kind of working out, well, you know, what's my next talk that I'm going to go to, booking yourself into the doctors, trying to walk through gates at an airport. Everything around us is being governed by a digital system behind which are algorithms, behind which are systems driven by code. Now, if we have a generation of people growing up passively using them, passively consuming what's shown them on a tablet screen or a laptop screen, that's perhaps fine, but you're not, by not understanding how that world works around you, how those systems work, how those decisions are made, you're not able to, one, make informed decisions about what's good and what's less good. You're also not able to hold to account those providing those services to you. You're not able to question and challenge an organization when it says, don't worry, we're only collecting metadata, that's fine. If you don't have enough kind of understanding to say, actually, I hear your words, but I still think that's dangerous. So you're in danger of having a citizenry that's not able to challenge the politicians and the organizations around us. It's a form of digital literacy and inequality, you know, and I think that's why it's really important for children not just to kind of learn to code for fun or to have careers, but actually to have a minimum level of understanding so that they can participate as an active citizen in the world. Okay, so that video didn't work. I think maybe the bandwidth. Let's come to the next slide. So some of the reasons why I think coding and learning to code is important. You might be surprised that it actually develops soft skills. Children who are learning to code, to create software products, are actually learning to work together, to collaborate, because they all bring different skills to it. Some will be thinking about users, some will be thinking about making sure things happen in order. Some people will be thinking about, hey, somebody's upset in the team, let's kind of make sure that they're happy. The problem solving, inevitably software projects hit barriers, and it's one of those, if you are a coder, you'll know that, you know, sort of 99% of the work is fixing things rather than, you know, everything going smoothly. So these skills, particularly, you know, for children who are between the age of 7 and sort of 14, if they don't learn that kind of resilience and that kind of acceptance that things don't go right the first time, so I think, you know, this is something they learn in a kind of more fun way. As I said earlier, I kind of enthused a little bit about, you know, children encouraging them to go into subjects like science, like mathematics, and the problem being that perhaps they're not seen as attractive, or perhaps they're seen as difficult. Well, actually, through attractive things like, computer graphics, computer games, products that they admire, in order to build them, in order to recreate them, in order to do that kind of work, you have to learn about mathematics, you have to learn about physics in games, for example, and it's a great way of kind of pulling people in. And I've seen that myself, actually. I've been really lucky that I've worked with children who are kind of at that kind of young, sort of 7 to sort of 14 age, and some of them honestly weren't that interested, but when you show them a game that they can create and code, they want to make the balls bounce, they want to know how things collide, and that makes them think, well, actually, I need to learn about comparing coordinates, or I need to learn about forces and what happens to the momentum of something when it hits the wall. And it's a great way of getting people into those subjects. And it's a broad field. It's not just about mathematics. It's not just about physics. People who are, like my daughter, who's much more interested in visual design. A lot of these digital products are a collection of disciplines coming together. So if you think about a computer game, it's not just physics collisions. It's about character design, landscape design, music. So children who are interested in music can come together as part of these software projects. And it sounds obvious, but actually a lot of people haven't kind of clicked on that. And I often talk to parents and teachers and say, there is a diversity of skills that are really needed in the creative technology sector. It's not just about people who are geeking out on, C++ or something particularly narrow. And the careers, are not just what you might call developer careers. Increasingly you'll see journalists who are coding. Is it Mike Cook on the BBC? He was showing off his Jupyter notebook as part of his kind of explanation of some economic point. That's becoming increasingly normal. If you can code, you are a much more attractive to employers. It shows that you can think logically. It shows that you can work with technology in an active way, not in a passive way. And it shows that you're kind of inquisitive about the digital world around you. I personally, actually, I know I've banged on about it a little bit, but I do think that if we have children growing up who are just passive, then that's a real inequality and power imbalance. We need us to be able to hold companies and governments to account, and we can only do that by having a level of understanding of how technology works. What does it mean when a company says, we're only doing X, Y, Z, or when governments try to say ban encryption? What does that really mean? What does it mean if I put something on social media? What are the implications of that? You don't have to be a low-level hardware programmer to understand what that could mean and what's possible in terms of what the bad uses of that. Here's just a little example from a kids' class where we're just demonstrating physics. So this is a real example of code. So it's just balls bouncing around, and in order to kind of do that, the children really wanted to learn, well, how does gravity work? What does it mean when something hits the edge and bounces? And I suspect, well, I don't know, but when I was a kid, the kids weren't going to the physics teacher and saying, tell me, how does gravity work? Tell me, how does momentum work? But through this kind of approach, I am seeing that kind of reaction, and that's amazing. Again, my daughter, she's more interested on the visual side, but she's already at a very young age thinking this is her direction. So let's talk a little bit about tools and what you might need to get or do at home if you have a child or if you kind of have children at school. And the good news is you don't need a lot, and it's not expensive, and a lot of it's free. So to get going, all you need is a browser. And we all have a browser, pretty much. You don't need to install anything. To get going, you can use websites like this one, and there are others, where you log in, type, click run, and it's done for you. Now that sounds to some people perhaps here, yeah, so what? But to some people, that's actually quite important because they are afraid of the technical complexity of installing things, the fact that something might go wrong, or the cost of software, or the worry about breaking something. Some of us might laugh because we're all kind of fairly literate in terms of computers, but for some people that's a paralyzing fear, and it stops them exploring and learning. But a website is just a website. It's not even here. And everyone can access that if they're on the internet. That's it. But you can obviously go further, and you can play with electronics, and I found that children quite like things they can hold and press buttons on. There's things like the Raspberry Pi or the Microbit. I particularly like this one because it's simple. It doesn't really go wrong. You just turn it off and on, and it's designed for children. It's got sensors for shaking and direction and lights. Is somebody kind of learning to code them? That's another one there. It's connected up to making a little loudspeaker for making sound. So it's super, super easy. You can even use kind of spoons from the kitchen to connect these things. They will work. You don't need expensive electronics to make these things work. And they're designed to be played with. They're not serious bits of kit. Nothing will happen if you break them. And in terms of computers, I know some parents I've unfortunately met who were worried about the cost. This is a Chromebook. In fact, it's a rather good Chromebook. You can get cheaper ones. In fact, I'm using it right here, and it's about 250 quid, 280 quid. It's got a fantastic HD screen, decent keyboard. You don't have to spend thousands of pounds on expensive computers. This will connect you to the internet, and it will run smoothly, and you can do a lot in terms of learning to code and using some of the services out there, including connecting things like the Microbit. It's all possible, and it's not expensive. So, looking at the time, how long have I got? I'll just do a little demo. And the point of the demo is to show you, if you haven't kind of coded or done this before, how easy it is. So I hesitate to ask people to put their hands up if they're already a coder, because you might be everyone. So who is a coder? Okay. Who isn't? Oh, that's good. Okay. This is for you. So we're just going to go to that website, Open Process, or you can register. You can say create an account. You don't even have to use a real email address because they don't kind of validate it. So if you're worried about privacy, I'm going to create a new sketch. There you go. Nothing to install, nothing to configure, no kind of language to kind of install, no IDEs. I'm going to enable a simple mode by clicking that button. And this shows a place where I type text. And that's no different from typing an email. It's just a browser window where I type. That's not scary. Now, because I'm setting it into simple mode, which is what I use actually for all my classes, I'm going to type simple. And over here, I'm going to delete what it did, because it put some code in already. Delete. And that's an empty kind of program where I'm ready to code now. So if this is designed for children and newcomers to coding, it should be intuitive. So what do you think the computer instruction is for drawing a circle? Have a guess. What would be the most obvious thing to type? Circle. Let's try it. Circle. Actually, let me make the screen a bit bigger so you can see the text. Can anyone see that? Yeah. Circle. Okay. Now, if I just say circle, will it know where it wants to circle? I need to tell it somehow. And that's traditionally done with coordinates like, on a map, like east, west, north, south. So I'll just say 400 along, 300 down. But it also needs to know how big the circle is going to be. Let's say size 200, let's say. Let's try it. And at the top is a little play button. There you go. If I click it, it'll run this code. There you go. You've written your first program. How easy was that? So everyone can do that at home. Children as young as 5, 6, 7 are finding this really comfortable. And I just re-stress the important point. Nothing to install, nothing to configure, no complicated stuff. And if I mess it up, it's okay. I just close the tab. I haven't broken anything. I can go in and have another go. Let's do some more. Let's make the circle a bit smaller. Let's say size 20. So it's a smaller circle. It's tiny, actually. Let's introduce a concept which is important in mathematics and computer science called randomness. So I'm going to ask the computer to pick a number, make a decision that's random. So I'm going to say, create a variable, like in mathematics, you might say x is 5 or x is 10. I'm going to say x is a random number from, say, 100 to 700. So that'll pick a random number between those two extremes, and x will be that number. So I can draw the circle at not 400, but at x. In fact, let me do that in the vertical direction as well. Random number between 100 and, let's say, 500. Let's see what happens if I run that. What do you think will happen? It should draw the circle, hopefully, in a random place. 1 minute. Okay. It's drawn the circle in a random place. If I run it again, it'll be somewhere else. If I run it again, it'll be somewhere else. Now, I'll show you one more thing, which is the idea of repetition. Computers are good at repeating things. So I'm going to copy this code, just copy and paste. And I'm going to create a function which is like a recipe, which you use again and again. So I'll call this function blob. And put the code in there, so when I use that recipe, it'll hopefully draw a circle. So if I say blob, if I do it a few times, blob, maybe it'll draw 3 circles. Now, what if I wanted to draw 100 circles? I'm not going to type that up 100 times. I might say repeat 100. Let's go crazy. 300. Repeat 300 times blob, which is that recipe we wrote. I've missed something out. Little error there. There you go. So that wasn't difficult, was it? You know, the concepts there weren't hard, and the coding is not that, difficult to do. So unfortunately, I've run out of time. I was going to sort of talk a little bit more about some of the kind of things that I've learned for kind of... Have we got a minute or two, maybe? We've run out? Okay, all right. Well, okay, well, I hope that you've seen how easy it is to get into creative coding, and that the tools are really accessible, and they don't cost anything, and they're not scary to install and run. Thank you for listening. All right.